Hello. In about the theoretical part of calculation of earthwork. Earthwork will be in two forms. One is in cutting, another one is filling. And we have different methods to work out the earthwork. Mid-sectional area method, mean sectional area method, and prismoidal method. And we have prismoidal rule and trapezoidal rule method also. Whichever the method is specified in the question, that you have to opt for. In the given question which I have taken now, they have not specified any of the methods. In this case, you can opt for any method. Here I have chosen the first method, that is mid-sectional area method, where mean depth is taken for the calculation of earthwork. Let us start with the problem. Estimate the cost of earthwork embankment and cutting. That means you have to work out if it is in cutting or banking, whatever the quantities are there, that you have to estimate for, and turfing of the slopes of embankment for the portion of road of 300-meter length. I'll tell you what is turfing in detail when that step comes. So you have to work out earthwork quantity as well as turfing area for the embankment for the portion of road for the length 300 meter from the given data. Formation width is 10 meter. Formation width is bed width. I'll show you. This is formation width. These are side slope. S is the side slope, that is S is to 1 is the side slope, and this width is called formation width. That width they have given, that is 10 meter. Side slope in case of banking, it is 2 is to 1, and side slope if it is cutting, then it is 1.5 is to 1. If you wherever you have banking, that is filling, there you have to take the S value as 2, and if you get cutting areas, there you have to take S value as 1.5. Still we don't know how the problem is, whether we need cutting or filling or both or only one of them. Once we solve the problem only, we will get to know that. They have also given the distance and the RL of the ground. They have done the survey, and they have taken the RL at every 30-meter interval. You can see at every 30-meter interval, they have taken these values. All these dimensions are in meters. All the dimensions, distance as well as RL of ground will be in meters. Usually it will be in meters. Here they have missed to give the dimension. Okay. They have got the RL like this. At 0 meter, the RL of the ground level is 101 meter. At 30 meter, 100.9. Like this, at each and every point, they have got this RL. They got the RL only at every 30-meter interval. Don't know, however, what is in between this 0 and 30 or 30 and 60. We don't have any values. Okay, let us continue with the question. The formation level at the first chainage is 102. Formation level means where we need the road. Actual ground level at the first point is 102, but for our road, the formation level, that means the RL at the formation level at the first chainage, that is at the 0th point, should be 102 meters. That means there is a gap of 1 meter. All those things we need to fill. That gap you need to fill. So the formation level at the first chainage is 102. The road is in downward gradient of 1 in 150. Downward gradient means the road is like this. The first point is like this. It is going towards like this. Downward gradient. This diagram is not given in the question. This is for your reference. I have written. This will not be given, any of these will not be given in the question. Up to 120 meter. They have taken the RL up to 300 meter, but the downward gradient, the slope up to 120 meter, the slope is in 1 in 150. Afterwards, the gradient changes to 1 in 100. See, first gradient is, if at the first point, if it is 1 meter, at the 150th point, it should be 0. This is called 1 in 150. At one point, if it is 1 meter, the slope 1 in 150 means after 150 meter, there is a drop in the slope. There is a slope, there is a drop of 1 meter. After a distance of traveling 150 meter, there is a drop of 1 meter. This slope remains same up to 120 meter. After 120 meter, the gradient changes to 1 in 100. That means if at the first point, if it is 1 meter, after traveling a distance of 100 meter, there is a drop of 1 meter, like that. This is the question. And then we need to take the cost of earthwork in cutting as rupees 100 per cubic meter, and cost of embankment. Embankment is filling at the rate of 110 per cubic meter. And for the turfing at the rate of rupees square meter. You can observe the cutting and filling are in cubic meter. The turfing is in square meter. I'll teach you what turfing is, don't worry. So this is the given question. Whatever the sentences, the statements and this volume values you are seeing, only this will be given in your question. No diagrams, nothing will be provided. So this is the given question. For your understanding, I have plotted a graph. This is not required. Just for your understanding, I have plotted the graph. Just to know how the given values are. How is the ground level? See, at 0th distance, the ground level is 101. RL of the ground level is 101. At 30 meter, it is 100.9. At 60, it is 100.5. Like this, if you plot a graph, on the x-axis is distance and on the y-axis RL of the ground. If you plot a graph like this, if you plot a graph for these values, you will get the ground level like this. So our ground level, present natural ground level terrain is like this. I'll show you. See, ground level is like this. But they want in the other way. They want to form a road on this. On this we can't put a tar road. And the traveling will not be so safe even if we do so. For this, we need to form a road. On this ground level, we need to form a ground using the data. How they want the ground, how they want the road, that is formation level. Formation level is after finishing what should be the RL. So the formation level at the first point is 102. That means at this point it should be 102. And they said the road is in the groundward gradient of, as I said, it is 1 in 150. For the calculation purpose, we need the RL at each and every chain edges where they have already taken the RL. That is at 30 meter, what should be the formation level, and at 60 meter, what should be the formation level. That like that, at each and every point, we need to find out the RL using the requirement which they have given. Okay. Now, see with this. That is, it is the slope is in downward gradient of 1 in 150. We need at every 30 meter, what should be the value here? or what should be the difference, this point. So we can use the cross multiplication concept. Here I have already calculated. RL of the formation at the zero distance is 102. The road is in the downward gradient of 1 in 150 up to 120 meter. For every 150 meter, there is a drop of 1 meter. We need a drop at every 30 meter. How to find out? For 150 meter, if it is 1 meter, for 30 meter, what is the drop? Do the cross multiplication. That is 30 into 1 divided by 150. So 30 by 150 will give you 0.2 meter drop. That means this difference is 0.2 meter. If you see at 60 meter, again the difference from this point to this 60th point, the difference should be 0.2. Like that, when you reach 150 meter, it will become 0. That is the concept. This is how you need to find out the formation level. Similarly, okay, we'll come to this later. Let us calculate only up to 120 meter. See, RL of the formation at 0th distance is 102. At 30 meter, there should be a difference of 0.2. Here, at 30th meter, the difference between these two values should be 0.2. That is 102 minus 101.8. Remember, since it is downward gradient, we should reduce this value. If they say upward gradient, that is rise, then we have to increase this first value with 0.2. Since it is downward gradient, the slope, the RL should reduce from the previous value. That's why 102 minus 101.8. So for the next value, there should be a difference of 0.2, 101.6. Similarly, 101.4, 101.2. They clearly said this slope holds good only up to 120 meter. Afterward, the gradient should change. So you should do this value reduction only up to 120 meter. After 120 meter, the gradient changes to 1 in 100. So similarly, if we do the calculation, for every 100 meter, there is a drop of 1 meter. For every 30 meter, same cross multiplication, that is 30 by 100. It will fetch a drop of 0.3 meter. That means for the next value, there should be a difference of 0.3, not 0.2. Up to 120 meter, there should be 0.2. And afterwards, the gradient, they are saying the gradient should change. So there should be a difference of 0.3 between these two values, 101.2 and 100 minus 0.3. 101.2 minus 0.3 will give you 100.9. And this should continue till the end of the chain age. That is, they have worked out up to 300 meter. So up to the end, you should give the difference of 0.3 between the consecutive values. This difference is 0.3, this is 0.3, this is 0.3, like this. Keep reducing with the 0.3 till the end. The last value will become 99.4. This is how you need to find out the RL of formation level up to here. Now let us plot a graph for this formation level. This is, I'm clearly telling, this is for your understanding. Unless they ask in the question, don't plot any graph. See, this is the RL of formation level. At 0, it is 102. At 30, it is other value which we got as 101.8, later 101.6, 101.4. Like this, it keeps reducing. I have plotted simple graphs also here. See, this is the natural ground profile we have. This is the formation level. I have just plotted the graph for the values which I got here. Okay. See, this is the actual ground level. This is the formation level. This area has to be filled. This quantity you have to work out. you can clearly see you need not to cut the earth anywhere. See, if this lines goes down beyond this blue line, then the cutting will happen. If this is the case of only this problem, it depends on the given conditions, given RL of the ground. In this problem, you have to only fill with the earth. No cutting is required here. Okay. I have taken the picture of this also. See, this is the actual ground level. This brown area is the filling of the earth, and with this quantity you have to work out. This is the cross section. You can see only area, but you need to find the volume of this. How will you find the volume? Let us see here. To find the volume, we need the D value. That means this depth. 102 minus 101, and this value minus here, this minus here, this difference you need to find at each and every point. That is, depth is given by RL of formation minus RL of ground. Always. This should not change. See here, this should never change. RL of, it is always RL of formation minus RL of ground level. It is not vice versa in any case. It is not RL of ground minus RL of formation. It is always RL of formation minus RL of ground. This value minus this 102 minus 101, that will give you 1. 101.8 minus 100.9. This difference will give you positive value. You can observe we got all the values as positive. This positive indicates only banking. That is nothing but filling. If you got this depth value in negative sign, it indicates cutting. So always you have to use the same formula, RL of formation minus ground level. If you do ulta, then this positive and negative differs and the whole problem goes wrong. So always remember, it is always RL of formation minus RL of ground level. If you get the depth values as positive, it means banking. If in between, if you get anywhere negative, that means that there you have to do the cutting. So in the given problem, there is only filling. This is only the case of this problem. Now we have already calculated the depth. That means whatever the depth we are getting at each and every 30-meter interval, that we have calculated here. This is how you have to solve the problem. Next step is this table. This is earthwork calculation table. This is like detailed estimation. So now you have to put a table like this. This is the table for mid-sectional area method. As I said, in this problem, they have not mentioned the type. I have chosen as mid-sectional area method because this is the easiest one. So B, that is formation depth is B is equal to 10 meter. And S is equal to 2 for banking. So if you have the cutting also, you can put a comma and write S is equal to 1.5 or whatever it is given for cutting also. We have learnt that in the mid-sectional area, the quantity is found like this. BDM plus SDM square multiplied by L will give the quantity. Now, in this table, it should contain serial number, distance, depth, mean depth, B into dm, S dm square, BDM plus SDM square, L and BDM. This is the final one. BDM plus SDM square into L. To get this, finally we should need this value. But until we get, we need to follow this table. Don't run or skip all these columns and write only this using the calculator. This is how you have to do the individual calculation in the individual column to get the full marks. Next, the distances. These distances we have from the data. From this table, you have to take the data. This is the distance column and this is the corresponding depths. These depths you have to put vertically. Actually, that is in the row wise, but in this column, the same values you have to copy column wise. Next is mean depth. Mean depth is the mean value of these two values, 1 plus 0.9 divided by 2. That will give you 0.95. I'll show you in the graph. This depth, at this point you have 1 meter. At this point you have 0.9. You are taking the mean depth here. That is 1 plus 0.9. That will give you the mean depth as 0.95 somewhere here. Using this, you have to work out this quantity. You are finding the values of the quantity, the volume of the earth this wise. That means at every 30 meter, what is the volume of filling that you are working out individually, and finally you are adding everything here. So mean depth, this 0.95 is the mean of 1 and 0.9. Next, 0.9 plus 1.1 divided by 2 will give this. Similarly, 1.1 plus 0.7 divided by 2 will give 0.9. Similarly, 0.7 plus 0.4 divided by 2 will give 0.55. Similarly, you have to do till the end. This last value is the average of 0.6 and 0.9. You will get 0.75. This is how you have to do. And the first row, you can observe it is full empty. It should be like this. This is the mean depth. Next column is BDM. This is for at the end you have BDM. So for that you have to work out B into DM. Value of B is 10 meter. So 10 multiplied by corresponding DM values. 10 into 0.95, that is 9.5. 10 into 1 is 10. 0.9 into 10, it is 9. 0.55 into 10, it is 5.5. Like that, you will get this column. You can easily work out in the calc using the formula. And next column is SD square, which we require here. Value of S is 2 for banking from the given data. S will be constant 2. DM is this value 2 multiplied by the corresponding DM values. 2 will be constant throughout, and DM value keeps varying like this. 2 multiplied this value square, SD square, that is 2 into 0.95 square will give you 1.89. 2 into 1 square will give you 2. 2 into 0.9 square will give you 1.62, likewise till the end. Next is BDM plus SDM square. It is very easy. Adding up these two columns. 9.5 plus 1.81 will give you this. 10 plus 2 will give you 12. Like this, you keep adding these two columns to get this column. Next is L. That is constant. Why this is 30 means we are working out this values at every 30 meter interval. This DM which you have taken, here it is 1 meter. Here the difference is 1 meter and here the difference is 0.9, and we have taken the mean depth as 0.95. That using that formula BDM plus SDM square multiplied by the length. Length is this. That is 30. At each and every interval is 30, 30, 30. So this depth, that area, you are working out this area. BDM plus SDM square will give the area of this. Will give the area at this cross section. At this point of cross section is BDM plus SDM square. I can show you here. This here. the D value is 0.95. B is BDM plus SDM square. This area we got, this trapezoidal area BDM plus SDM square, this area at which point? At this point. Now, that cross-sectional area multiplied by this difference, that is 30 meter, will give the volume of earthwork that is filling only up to this point. Similarly, in the next value will give the volume of this. Here. So this is the first difference volume. This is the next volume. This 339.15. See, 11.31 is the cross-sectional area at this point. And 339.15 is the volume of this point, this content. Similarly, this 12 is the cross-sectional area here, multiplied by length, that is 30, will give you 360. This 360 is the quantity of filling of only this portion. Similarly, whatever the quantities you got, 318, whatever the quantity you got, that is the volume of only this areas, this 30 meter interval areas, volumes. So to get the complete volume, what you have to do to get this complete value of filling, volume of filling, you have to add this, column. So if you add it, you will get 2362.05. This is the total quantity of earthwork in banking. So this will give you how much mud is required to fill this area to have a proper road which we require. That is, which is the requirement of the problem. Okay. This is the detailed estimation. In the next video, I'll teach you about that how to calculate the turfing area. Area of turfing I'll come up in the next video. Right now, you keep practicing this. Thank you.